1, let's see the chapter 4.4, graphs of secant and cosecant function. Do you remember what is reciprocal of tangent and, cosecant and secant? Secant x is equal to 1 over sine x, and secant x is equal to 1 over cosine x. That means the function of cosecant has a relationship with the sine. If I can graph a sine function, so I know that one full cycle is from 0 to 2 pi, and I can keep graphing more cycles. So the reciprocal of a sine is cosecant at these x-intercepts of the sine. So let me clear the board. So at these x-intercepts, this is x-intercepts, I can draw vertical asymptotes. And then let's have the head-to-head graph. Head-to-head. So these graphs are the function of cosecant. Cosecant is the reciprocal of sine function. How about the secant function? For the secant function, is reciprocal of cosine. So I can graph cosine function first. So cosine function is peak to peak is 1 full cycle. I can graph more cycles. And what is the x-intercepts? At the x-intercepts, we can draw vertical asymptotes. And then do the head-to-head. I mean the head-to-head. Or bump to bump, you can graph is reciprocal functions. It's very messy. From the graph, we can do some conclusions. And for the cosecant, what is the domain of the function? Domain means all the x value. That means the x is not equal to these vertical asymptotes. These vertical asymptotes is integer n times pi. You see 0 times pi, 1 times pi, -1 times pi, 2 times pi, -2 times pi. So x is not equal to n times pi. And how about the range? So from the graph, you can tell that the range means all the y's value. And we have y's value. So from y is equal to 1 all the way up. And from y is equal to -1 all the way down. So the range of the function is from -infinity to -1 bracket union 1 to infinity. And for the domain, x is not equal to n pi. And for the vertical asymptotes, x is equal to n pi. And this image is secant. For the secant function, what is the domain? So x is not equal to these vertical asymptotes. These vertical asymptotes, they are odd number, 2n plus 1 times pi over 2. So this is the domain. How about the range? They have the same range as the cosecant function. It is from -infinity to -1 bracket union 1 to infinity. So when I'm editing the lecture notes, I forgot that these are the brackets, not the parentheses. Okay, and all of them, they have the period 2 pi, because bump to bump, the period of the sine cosine, they are 2 pi. So they also have the same period is 2 pi. And for the cosecant, this is 1 over sine x. Function is an odd function because sine function is odd function. And secant is 1 over cosine. Cosine is an even function. So secant is also an even function. Okay, how to graph them? We should graph its reciprocal first. and then do the bump to bump or head to head. Okay, let's see the first function. If this is an easy one, we just say 2 times of my secant function. I just stretch vertically of my secant function. But if I want to follow the steps above, so we can say, let's graph y is equal to 2 times cosine first, because reciprocal of secant is cosine. And replace the secant with cosine x. Let's graph cosine first, 2 times cosine first. So how to graph 2 times cosine? So we say bump to bump, and this is 2 means vertical stretching 2 times. So mother function is from bump 1, 0, and -1, and 0, +1. So this is a function of cosine. 2 times cosine, we can use different color, stretch vertically. This is 1 full cycle, and I can keep graphing it. Keep graphing it. All right, and how about its reciprocal at the vertical asymptotes? So let's draw the vertical asymptotes. And then we can do the bump to bump. This is a bump to bump. We can use different color. Which color is best? Let's use blue. No blue. Let's use this color. Bump to bump. And bump to bump. And then bump to bump. Okay. Now I can erase all of the helping informations. So this is a graph of 2 times secant x. All right. How about next one? Example 2, graph the cosecant function. Here I give you the hint. We can graph the sine first, because reciprocal of cosecant is sine. So let's graph sine x minus pi over 4 plus 3 first. So the previous one, we just say find the stretched cosine. Now, finding the function sine. This one has more transformations. We can use the table. Okay, first I want to find the 1 full cycle. So for the sine, 1 full cycle is from 0 to 2 pi. So we can bounce the input x minus pi over 4 between 0 to 2 pi. And then solve for the x. So x is bounced between plus 4 pi, everybody, pi over 4. And then plus pi over 4, we have 9 pi over 4. Yes, 8 pi plus, okay, pi over 4. All right, so in the table, we're going to have 5 key numbers for the sine. This is x. This is y is equal to sine x minus pi over 4 plus 3. So the 5 key number, first and last, they are pi over 4, 9 pi over 4, and in the middle, we're going to find what is 1/4 times the period. So the period p is equal to 2 pi over b. 2 pi over b. In this question, b is 1. b is the coefficient in front of the x. So we can evaluate this is equal to pi over 2. So based on the pi over 4, based on the first one, we plus pi over 2, we are going to have 3 pi over 4 plus pi over 2, 5 pi over 4 plus pi over 2, 7 pi over 4. Okay, so how about the y's value? Do we have any y transformations? Yes, we have plus 3. So based on the sign, so in my mind, I must have the graph of the sign. So what are the 5 key information? What are their y's value? First, y is equal to 0. So 0 plus 3 is 3. Second key point is 1. Y's value is 1 plus 3, 4. And 0 plus 3, 3. Negative 1 plus 3, 2. And the last point is 0 plus 3, 3. All right, we have these key points. Let's graph them. And remember, this is a sine function, not a cosecant function. So pi over 4, comma 3, pi over 4. So pi over 4, where is the pi over 4? Okay, so here is pi over 4. Pi over 4, comma 3 is first key point. Second, 3 pi over 4, comma 4. Okay, here. And the 5 pi over 4, comma 3. 7 pi over 4, comma 2. And 9 pi over 4, comma 3. So we can use some dasher curve, but I didn't. It's okay. So this is one full cycle of y is equal to sine x minus pi over 4, then plus 3. So at the, we know that now we do not have the x-intercepts, but we can have a center point, center line of the sine, and then the point on the center line, I can draw the vertical asymptotes. So let's draw vertical asymptotes here, here, and here. Then we can graph our reciprocal function, bump to bump, or head to head. This is cosecant function, cosecant function. All right, we're done. We can also erase our helping informations. For example, I can erase a helping function. So this is the cosecant function. All right, let's see number 3. Identify the function. Let me see how many questions. We have 3 questions left. Identify the function. Obviously, this is cosecant function or secant function. I don't know is cosecant or secant function, but I can find the center line of the sine or cosine. So here is 4, and this bottom, this bump, the y's value is 0. So between 4 and 0, the middle line must be 2. So let's find the middle line or center line. X is equal to 2. All right, now let's find vertical asymptotes. Vertical asymptotes. My graph is getting so close to it. Okay, and the next step is find our reciprocal function. So bump to bump, bump to bump, bump to bump. Okay, from this graph, can you tell me it is a cosine function or sine function? Obviously, it's cosine function. I can keep graphing because I know it's from bump to bump. It's cosine function. Okay, let's put it is cosine function's reciprocal is secant. It must be a secant function. I want to find the cosine first. So this is cosine function. And there is no horizontal shifting because it's not going to the left or right. So I can put let's put bx here, no horizontal shifting. Do we have any vertical shifting? Yes, because for the cosine function, center line is at 0, x is equal to 0. Now center line, x is equal to 2, moved up 2 units. So I'm going to plus 2. And how about the stretching? So stretching for the cosine function, and we know this is 1. Okay, this is 1. It doesn't let me to write. Okay. This is 1. This is -1. So from the center line, go up 1 unit, go down 1 unit. It is my amplitude. So let's see if I have some amplitude. For example, let's put a in front. So based on the x is equal to 2, we are going up 2 unit to get the bump of the cosine. And going down 2 unit, I can reach my lowest point of the cosine. That means stretch vertically 2 times. Okay, I can change the a to be 2. Okay, last one is decide the b. Because no horizontal shifting, so we only have the bx in the input. So how to find the b? What is the period from this image? So period is between the bump to bump or dip to dip. So I can pick 2 points from the graph. So I feel this point and this point looks good because dip to dip, and the next full cycle is also from the dip to dip. So the distance, the x value between these two must be my 1 full cycle. So from -pi to pi is 2 pi. Oh, the period is 2 pi. And period has a formula, is equal to 2 pi over b for the cosine and the sine, and the secant and cosecant. So I can solve for the b. B must be 1 because 2 pi is equal to 2 pi over b. B must be 1. Okay, b is equal to 1. So I can rewrite my cosine function is 2 times cosine x plus 2. And we are not looking for the cosine function. We are looking for the function 2 times secant x plus 2. So our solution is 2 times secant x plus 2. All right, let's see next example. Number 4. Also, I want to graph my function. First step, I want to find the bump. So here the bump is mapping to y is equal to 3, and the bump here is mapping to y is equal to -1. The middle line or center line of its reciprocal function must be 1 because the distance between them is 4. So in the middle must be y is equal to 1. So let's clear the mess. And then draw the center line. So x is equal to 1. And then let's find the vertical asymptotes. So vertical asymptotes. We don't have to graph a lot of vertical asymptotes. I think 2 vertical asymptotes are enough to graph 1 full cycle. But this one has more period. So we can graph all of the vertical asymptotes here. Okay, let's do the bump to bump. So let's use red color. So bump to bump. Bump to bump, bump to bump. Or head to head. All right. What can you see if I'm focusing on this cycle? This is a sine function. Okay, so let's say my sine function y is equal to, let's say a times sine bx plus d. Because I see there is no horizontal shifting, the initial point is starting from 0, 0. That's the reason I can make my input easier, not bx plus c or minus c. Okay. So it's very messy. So first, let's see, do we have any vertical shifting? No, because my one full cycle, so I highlighted, is from y is equal to 0 and then to the y is equal to 0. No vertical shifting going up or down. So I can erase the d. And how about the a and the b? So a means from the center line and going up and down to find the so a absolute value of a is amplitude. How high of, what is the height of my wave from the center going up and down? So from the center line, I'm going up 2 unit. I'm going down 2 unit. That means my a is equal to 2. No reflection. How about the b? Okay, let's see. I want to make it clean. So from this point to this point is one full cycle, and the one full cycle, the x value is 4 pi. That means p period is 4 pi. The formula is 2 pi over b, and b must be 1 over 2 or 1/2. So we can solve for the b. We're using 2 pi over 4 pi is 1/2. We found all of the a and b's value. So y is equal to, a is equal to 2. 2 times sine 1/2 x. We're looking for its reciprocal is 2 times cosecant 1/2 x. Okay. Let's see next example. This one we want to identify the function, and we do the same thing. Find the center line. So it's from 1 and -5. So distance between them is 6. So we can highlight -2. Because from here to here is 3, from here to here is also 3. Okay, let's highlight. Let's make a dash line. And we say this is a center line of its reciprocal function. And then what are the vertical asymptotes? So let's find vertical asymptotes. I don't want to graph a lot of cycles. Vertical asymptotes. I think that's enough. And then use different color to do the head to head. So from this image, I can tell this is a sine function. So we can put y is equal to a times sine bx plus d, because there is no horizontal shifting. Initial point is starting from x is equal to 0. There is no horizontal shifting, and also there is no reflecting. Okay, do we have a d vertical shifting? Yes. So it's shifting down 2 unit because it's going down 2 unit. So d must be -2. And how about vertical stretching? So from the center line going up 3 unit, going down 3 unit. That means vertical vertical stretching is 3. So let's put A is equal to 3. And finding the B, we can find the B from the period. So the period from 0 to 2, that's 2. So we can say P is equal to 2. Also equals 2 pi over B. So B must be pi. So y is equal to 3 times sine pi x minus 2. And we're looking for its reciprocal cosecant. Y is equal to 3 times cosecant pi x minus 2. Okay.